I'm Noel Weichbrodt, Principal Engineer at Spokestack. Let's talk about why voice is just another interface. You might think of voice as the final frontier, something mysterious, something that's out there, something that needs to be explored, maybe isn't ready. It's actually not true. The future is here. 81% of us own smartphones, and of those 81%, 52% use voice assistants on their smartphones. Also, 43% of us have searched using our voice on our phone. Why is voice important? Well, consider this example. Which is easier, typing in what tea you want, or just saying, computer, tea, Earl Grey, hot? To understand why voice is a future of interfaces, let's take a look at the past. The very first computer interface that we used were punch cards, starting in about 1890 and continuing all the way until 2012, believe it or not. In 1910, the first keyboard and digital display were introduced. And in 1968, Douglas Engelbart gave the mother of all demos, in which he debuted a mouse and CRT monitor. In 1973, touchscreens entered production. And in 1989, remember the Nintendo Power Glove? Yeah, gestures and haptics became another way that humans and computers could interface with each other. Starting in about 2010, voice also started becoming another viable way for humans and computers to talk. Since we're talking about interfaces, let's give a little vocabulary for how voice interfaces work. Think back to the first example I gave. When I say computer, that's a wake word. A wake word is a signal for the computer to begin transitioning from passive to active listening. Next, I would say tea, Earl Grey, hot. That's all transcribed by the computer using automated speech recognition, or ASR. That turns your speech into text. Natural language understanding, or NLU, turns that text into commands that your computer can execute. When your computer is ready to respond, it responds with text-to-speech, or TTS, using a synthetic voice. So let's put all those vocabulary words together into our example. When I say computer, that's the wake word that grabs the computer's attention and transitions from passive to active listening. Now as listening, I say tea, Earl Grey, hot. The computer transcribes that and turns it into text and sends it along to the NLU. The NLU takes that text and derives what's called intents and slots out of it. You can think of intents as commands and slots as parameters. For example, make organic matter could be the command. What kind of organic matter? Well, tea. What kind of tea? Earl Grey. Anything else? Oh yeah, it's hot. Okay, I'm going to make some important sounding beeps and boops while I replicate that tea. When it's ready, I can use the TTS system to speak back using a synthetic voice. Captain, your tea is ready. If the voice interface is so natural and easy, what took us so long? Well, let's take a look at the year 1988. In that year, the state-of-the-art ASR accuracy was just 90%. That's measured using a word error rate, the accuracy of the words that you speak versus the words that are transcribed. Humans have a natural word error rate of about 4%. State-of-the-art in 1988 was over 90%. Out of every 100 words that you spoke, the computer would misrecognize 90 of them. Fast forward to about 1999. We've done a lot of research. We've gotten a lot better. The word error rate is down to 12%. Still not great. Fast forward to 2011. Something big happened. Some magic. The magic is machine learning. Machine learning turns out to be really good at turning speech into text. So good that between 2011 and 2019, the state of the art has gone down to 2.9%. NLU and TTS accuracy have followed similar paths. The state-of-the-art NLU accuracy is about 90% in deriving intents and slots across corpora. TTS, similarly, is measured using a subjective score called a mean opinion score. 1 is the worst sound you've ever heard. 5, the sound of angels singing in your ear. Humans score each other at about 4.5 out of 5. The very best TTS systems score about 4.2. Not great, not terrible. But put together, it's enough to provide a great voice interface. Imagine your app's voice interface using Spokestack. Spokestack removes the barriers that are standing between your app and your user's voice. How do you do it? Spokestack provides a clean, simple API. call Start to start the Spokestack speech pipeline. Once your user starts talking, you get the text back. Once you get the text, you can call Classify on the Spokestack NLU. That gives you intents and slots, and your app can do its magic from there. Once it's ready to respond, you can call Speak on the Spokestack TTS and read back your response using synthetic voices. Let's talk about privacy. Spokestack cares about privacy, which is why we open source all of our mobile libraries, so you can verify our claims. For example, we don't store any audio that's recorded while we're waiting for the wake word activation. And you can verify that using our open source libraries. Once your user starts talking, you have a choice of which ASR provider to use. Use whichever one you're comfortable with. Our NLU runs entirely on device. That means no data is sent up to a cloud of some big tech company. It stays on device, safe, with your user. And our TTS system runs on our own private cloud. So is voice still the final frontier for you? With Spokestack, you can bring that future into your app now. Come explore the final frontier with us at spokestack.io and give your app a voice interface.